Good morning guys, I'm Chris and welcome back to this Sunday's episode of Rift Amps. AC10 update. So the amp is not finished yet, but I want to show you where we are on this. I have gone through and I have given it a recap. I have done the main multi-section cap, that one there. I have done the other dual section cap, the 8+8 cap that sits on the preamp side of the chassis, that one there. Done the bypass cap in the output stage and two 25 microfarad caps that sit in the preamp. So fired this thing up and there's no output at all. Immediately noticed there was no output. Why would there be no output? Well, unfortunately, there was no output on the what am I trying to say here? Yeah, on the vibrato channel. The normal channel was working fine, and I located it down to this 22k resistor here, which is R17, which sits here. Okay, this is the internode dropper, and you see from this point here it feeds the tremolo oscillator, but it also feeds the EF86, which is the first input stage of vibrato inputs. Now, interestingly, it hadn't blown completely open, but it measures almost 20 meg. So it gone it so high, but it hadn't blown open yet, and so we're getting roughly 1 volt here when we should be getting many times higher than that. So replace that resistor, put a new one in. There was also the, where is it? This 820 ohm resistor for the normal channel was measuring 2k. It's now here, so that's been swapped out as well, and the amp has come back to life. It's not perfect yet, there's still a lot to do, but I've got a microphone up against the speaker so you'll be able to hear. So we'll start with the normal channel. You can hear we now have some hiss. Remember, the tone control works backwards on these, so that's no treble, all the treble. That channel's now working, but it does have some noisy anode resistors, so we're going to have to find those and sort those out. This channel, however, I'll show you. You can hear we have quite a strong tremolo that has returned. Some DC on that pot, so we need to fix that, but you can hear that's maximum intensity, that's minimum intensity, and you can still hear it throbbing. Okay, you can clearly hear that oscillation now. The low frequency oscillator is now working. Is it working great? No, it's not optimal yet, but we're going to work on that. But do you remember the issue was at amplitude there, that previously in the test you couldn't hear it at all. Now you can hear a definite throb. So we are moving in the right direction. Great news. Okay, so now I've got the amp up and running, I can now start to service it and refine it and getting it where it needs to be. So that means going through, checking components as required, checking voltages, make sure they're in the range that they need to be, and once I've got all of those issues sorted, then we can finally look at his complaint that it's picking up radio signals. But I just wanted to give you an update on where this one is so far, what it's doing, what it's not doing. But good news. Quick update on this PR18 build. Almost done. Board is in, all wired in. Just got to have a quick tidy up. I've started the heaters, just need to finish those off. Then I can do just my flying lead, not my flying leads, my shielded wires from the inputs and from the volume control over to V1. Finish off my mains wiring, and then I can fire this one up. So this one's nearly done, coming on great. Really, really happy with it. It's actually a slightly updated version for 2025, although the customer has requested that he doesn't want the half power switch, which is why that's missing on this particular amp. But yeah, it's a slightly different updated design for 2025, which I'm really pleased about. Yeah, really, really cool. So this one is, where's this one going? Somewhere in Europe. Anyway, cool. Crack on. When you've been doing this stuff for as long as I have, God, that sounds awful, doesn't it? It makes me sound really big-headed. But that's not what I mean at all. What I mean is, it's very rare that you get an amp through the door that you've not worked on before, or worked on that particular model before, would be a more accurate thing to say. When you do amp repair and servicing, you get lots of fenders, lots of Marshalls, a couple of Voxes, PVs, you know, all the regular, all your favourites, right? But it's when you get an amp through the door that you've not seen before, it's, you know, it's a bit different. You've got to reactivate those brain cells, because, you know, having not worked on one of these before, I don't know if they have any common problems. I don't know what they're like inside. It's all new to me. It's a new experience. So, yeah, really interesting. This is, as you can tell, a Music Man 112 RD50. Now, as far as I know, these are part solid state part valve. I think that's right. And this is actually owned by the same customer who had the super, super clean Pro Reverb. And he's brought with it the original owner's manual for the RD and RP series of Music Man amplifiers. What's the difference between RD and RP? Shall we learn together? The RD series combines state-of-the-art vacuum tube design with built-in reverb and foot switchable distortion. You got that? The RP series combine the state-of-the-art vacuum tube design with built-in foot switchable phaser and reverb, plus adjustable distortion circuitry. So P stands for phaser. So does that mean the RP are the same as these plus phaser? I think so. I think so. Oh, the R in RP stands for reverb. The P stands for phaser. On this side, the R stands for reverb. The D stands for distortion. Okay, interesting. Cool. Very nice. Very nice old bit of kit. Isn't it cool that people keep this stuff? Explanation of what's what and how these things work. Picture of the original foot switch. Simplified block diagram. How to wire stuff up. Love it. Love it. And the amp specs. Okay, so the RD. Oh, this doesn't include the 50. The 50 is not on there. Don't know. And he also brought with him as well a schematic for. I don't know if it's whether it's the correct schematic for the amp, but it is a schematic. So very cool. Anyway, so what's it in for? Why is it on my bench? Customer complaint is check low note flub. He said, so there's clearly something going on there that he's not happy with. Pops and crackles at idle. Give it a service, and he wants a pat test. Well, we can do that. We can do that. So anyway, let's zoom in and have a look at the Music Man RD. 2 channels by the looks of things. labelled, well, we've got a bright switch here, volume, treble, bass, and then single input. Then we've got a switch here, limiter and clean. So this must be the distortion channel. Volume, treble, bass, gain, and the reverb control at the end there. Can you see? Yeah, you can. On, power off, Music Man Inc., Anaheim, California. Very cool. I don't know how old this is. Is it 80s? As I said, I don't really know much about these. But I'm keen to learn. Keen to learn. Let's spin it around. It's in nice condition because, just like the Pro Reverb, it's been generally kept inside and looked after. Can you see what's going on there? You can. I guess serial number 8111. Oh no, serial number EN07324, model 112 RD50, 240 volt, 50 hertz, 50 watt output. Cool. Okay. With a Music Man speaker. Now that looks to me like the stuff Eminence were chucking out back in the day. That's what it looks like to me. I'm probably wrong. I'm nearly always wrong on this stuff, but you know, here we are. Let's buzz this off, this panel off, and get ourselves a good look. There you go, couple of 6L6s. Couple of 6L6s. What else have we got? We've got a 12AX7 7025, I believe that says there. Fender branded. Very cool. Okay, well, I'll look at one of these output valves. 6L6s, Jan Phillips. Expensive set of valves now, those are. Wow. Oh, you can see me. Hello. Right. So before we pull this thing apart, let's plug it in. See if we can hear some of these noises and artifacts that the customer is complaining about. I think that's a good idea, don't you? Yeah, let's do that. I seem to remember the customer telling me that he replaced this grill cloth himself, which is probably why it looks like it's in such nice condition. Probably. Okay, 2 seconds. Right then, so what we're listening for, pops and crackles at idle. So let's put all the controls at 5. Apart from reverb. Oh, no, I'll put reverb up as well. Everything at 5. Don't know. Let's go. Okay, enough of that. So sounds all right to me. Usual amount of hiss for an amp of this particular era and style. I mean, I've got everything dimed there, so I'm exaggerating how bad it is. There's a slight background hum there when the volume control is all the way up, but it's certainly not intrusive. Okay, bit of switching noise there, but again, not uncommon. And again, I've got this in an exaggerated state, so it sounds worse than it truly is. Right, let me grab a loop, and we'll just run a loop through it and see if we can hear this bottom end. This is a cool amp. This is one of Ainsley's old Marshalls, model number 2144, and this is the one that was modified and inspired us to do the signature amp. He brought it in the other week, and because one of the output valves kept red plating, went through it and found on the underside of the circuit board that one of the PCB traces that had previously been repaired had failed again. So that's now been fixed and it's back up and running and sounds great. Maybe next time he comes we'll do a sound sample of it, I don't know. But yeah, obviously I'm not going to show you inside it because there's some really cool things that a lot of people want to know. But yeah, that's the old black Marshall, the one that was highly modified at some point in its life. He picked it up in Switzerland and it's got a really, really cool, unique sound. And that's the inspiration for his signature model. Right, apologies, this is going to sound rubbish because these microphones are not great at picking up high quality audio, but at least we'll be able to get a basic listen as to what's going on. They just struggle with high volume, just the way it is. But anyway, here we go. Okay, we'll stop that, yeah, because on that distortion channel, that bottom end is ugly. Yeah, flub is the perfect way to describe that. I hope it came across on camera. If it didn't, I'm sorry, but you'll have to trust me. But yeah, that did not sound nice at all. So, okay, let's pull the chassis, have a look inside, shall we? Okay, so the Fender similarities continue. Was this the era that Fender owned Music Man? I'll look it up before the video goes out, but yeah, let me know down below. Transformers, it's got Schumacher transformers. Dated 39th week of 1981, the output transformer. The mains transformer, 40th week of 81. Very cool. Okay. Should we have a look inside? Let me get a chassis stand. Can you see? You can. What do I see? Well, I see a PCB with big old components on, like that. Okay. It's very clean inside. Very clean indeed. Very clean. You can see the chassis, how shiny it is over here. Just like the Customer's Pro Reverb, it's just very well looked after. So we've got some bits and pieces. Do I see a cap not looking very healthy there? No, it looks alright, doesn't it? What have we got along here? You look alright. What about the Mallory, big blue Mallories? Oh, we need to see the other side, don't we? I was always going to cut you off. We'll come to those in a minute. Apart from that, very nice. Look at this. I guess it's what you'd expect an 80s Fender-y style amplifier to look like inside. Part PCB, part hand-wired. Yeah. They're still using carbon comps at that point, were they? Brown, green, yellow. 154. 150Ks. Yellow, violet, orange. 473. 47K. It's very clean. It's very clean indeed. Very nice. Okay. Let me just show you the end of these caps. I'll spin the chassis around. There you go. See an issue with those? Certainly not bulging or leaking electrolyte, are they? But that doesn't mean they're any good. They're definitely not knackered because there wasn't excessive hum. But that's where we are. Okay. That's the Music Man. Is there anything else that I can see that looks 11281 is written inside. It's American, so that's going to be November the 2nd, isn't it? Which lines up with those transformer date codes, actually. Apart from that, I don't see anything that's burnt or knackered or blown. All looks pretty nice to me. So we're going to have to do some further investigation. As I said, I never seen one of these before. I haven't been inside one, haven't worked on one. So I've got to go through that whole learning process too, do circuit familiarization, see if I can find the correct schematic online, find out where voltages are, where they should be, where they shouldn't be, and take it from there really, and just give it a general health check, stick it on the scope, check that everything appears to be working fine, there's nothing weird going on, and go from there really. Are we fixed bias? Cathodes are there's wires coming off the cathodes, but I don't know where they're going. Does this schematic give us a clue? Pin 8s tied together to ground, maybe. Okay. Need to get the correct schematic so I know what I'm looking at. Very interesting though. I thought you guys would find this thing interesting too. I hope you have. Yeah. I didn't hear any major... So what was his complaint? Pops and crackles at idle. I didn't really hear anything. It could be valve sockets and things like that, so we'll go through and check those. But this low note flub, definitely on the distortion channel. See if we can isolate what's going on there and why. We'll go through it, we'll scope it out, we'll do some further testing. See if we can find anything that is untoward. Right, just going to start marking out the next two. Actually not the next two because I'm already working on the next two, but the next two after that. I need to list the signature amps. So most of you have seen me do this before, but for those that haven't, I'll explain what I'm doing and why. Also, thanks to Stuart for my new pencil sharpener. Very cool. Or it leaves a massive taper. Amazing. Right, so I don't, for those that don't know, for most of my app builds, I don't have the chassis pre-punched. I do all the punching, drilling and marking myself. You might ask why, you might think that's silly, and that's a valid question. I get that. But what I've found over the years, and the way I prefer to work, is one, that I, as you know, my ethos is to constantly improve everything all the time. So every amp needs to be better than the last one in some way. And so having that flexibility at every stage of the build process is important to me. One thing that often happens is that if you do things in batches, you know, so I did 10 of these and I make a mistake, well, I've made that mistake 10 times, okay? And I'm therefore living with that mistake for a long period of time. You know, accidentally putting a hole in the wrong place or whatever. Where if you do them one or two at a time, that never happens. But also it allows you, after every amp build that you've just finished, you can then say, actually, I'm going to move that to this position. It will be better if I did it this way. And so having that flexibility for an app builder like me, in the numbers that I do and the way I choose to work, is much better. So that's what I do. Case in point, here's the original mark-out diagram for the Ainsley listed signature, just for the top side of the chassis, or bottom side, whichever way you want to look at it. And things have changed over the years. I've moved things higher or lower. I do actually have a drill template, but as you can see, I've already added no, 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 and no to certain points, because I've decided to move these in the future. So this is why this is kind of, it's useful in some ways, but it's pointless in another, because these things are constantly evolving, and I'm always trying to make the best product I can. Never want to stay still. So anyway, I've got to get these two marked out. And I'm going to give you some insider tips and tricks for those that are new to this and don't know how it all works and what I'm doing. So I like to use these blank chassis. These are 2mm aluminium, and I buy them in blank like this. The only punch holes they've got punched are the mounting holes. Okay, and I buy them in like this. I then send them off, and I get the corners welded up for extra strength. That's really important, especially when you've got big heavy transformers and you're hanging it from the ceiling of a cabinet, as I like to do. So having that extra strength there, really important, and that's a good thing. But I generally follow the same set of principles when I'm doing a layout and marking things out and doing all that stuff. And the first datum line that I draw is the center line for all of my valves. I like to have them all in a line along the chassis, and the way I do it is 1¼ inches up from the bottom edge. Like so. Really easy. Swap these over, do the same on this one. The other thing I have to make sure is that, as you can see, my mounting holes, they're not equidistant from the front and the rear. So I have to make sure that I always have the chassis in the right orientation. I have the larger gap on the mounting points towards the front, and I mark that with an arrow. That way I always do them in the right order, in the right way around. And that's great. So I'll get my datum line there, 1/4 inch up, 1¼ inches up from the rear edge. And then I do the same measurement in from this side. And that is the position of V1. That's easy enough, isn't it? From there, I can get my super long ruler, offer that up, line that up there, 1¼ inches, and I can then go along and mark on all the other positions that I want the valves to be. and I often work in Imperial. Okay, so they're all marked on, and if I get my template, I can check that those marks I've made do line up with the holes I've already got on there. That's easy enough. Okay, you see how that worked? I'm just going to then go on and do all the other marks that I need to do. Now, I am slightly wary because I can't remember. If I've already made the adjustments that I need to make or not. So what I'm going to do is, the other reference point that I need is one down here, which is 1/2 inch in from the side. Sorry, 1/2 inch in from the bottom. This is my safety earth point, my safety earth bond. And it should be 16.5 inches. And as this is a 17-inch chassis, that should also be 1/2 inch in from that side. There we go. So I'm going to put one there. So when I offer this up, check everything lines up again. It does. And from there, I can now make sure I'm happy with everything. Just go on and mark the rest of my holes in exactly where I want them. Perfect. See how that works? And I'll just go ahead and do exactly the same on this one. So if I go, the other reference point was there, and there. Make sure it's the right way up, top to the top. Everything sits exactly where I want it to be. Perfectly there. Let's mark some holes. Job done. Okay, and so what I'll do now is I'll go onto the drill press and I'll drill all these out pilot holes, go through all of them, and then I can enlarge them to where they need to be. It's as easy as that. It's not difficult. Progress on the on one of the 1-watt builds. This is not the 1-800 heads. This is a custom 1-watt build that I'm doing for a very nice chap. The chassis is now fully drilled and populated. I've got everything in exactly where I want it to be. Transformers are mounted, sockets are in. Very cool. Board is done. You've seen this before. It sits in like that. So I can start to make some very, very basic, what am I trying to say? Chassis wiring progress. Do as much as I can in the chassis, get as much of that done as possible, then I can drop in the board and do the rest of the connections. You know how it works by now. But that's coming on great, so really happy with that. Yeah. Before we go then, quick output check on the bench. Into 8 ohms, 150 millivolt RMS sine wave, 1 kilohertz, injected into the front end. I'm currently in the clean channel. Treble and bass on 0, bright switch is off. We're not in the second channel at all. And I'm getting, if I'm being generous, just there, 20 volts RMS into 8 ohms, which gives us exactly 50 watts. Okay, cool. If I just flick the bright switch, we get quite a boost there. Bring it back. Cool. Okay, treble control does what we expect it to do. Bass control does what we expect it to do. Okay. It's healthy at 50 watts, right? And that's bang on. It's very rare that they hit the number perfectly. Second channel. So just the volume control. We're getting 20 volts again, so 50 watts. Gain control does boost it. We're getting 24.5, which is 75 watts. Okay, cool. Treble control does what we expect. Bass control does what we expect. All seems to be working as we expect it to. Okay, so more investigation required. Well, that's it then, guys. Thank you very much for watching once again. As you can see, we are this close to 5,000 subscribers. So if you haven't subscribed already, please do. You're really going to help the channel out. So as always, please give this video thumbs up. All your comments and questions down below. Hit the notification bell so you know when I put out new videos. I've got more train wrecking coming and part 11, or was it part 12, of the Christmas special basement rebuild coming. If you're feeling super generous, you can, of course, always join the channel like these guys did, and I will catch you all at the next one.